Hello, good afternoon, my dear students. Welcome to Infinity Line NEET YouTube channel. This is Suresh, Faculty of Chemistry from Infinity Line Studio. Today we are going to discuss about the chemical kinetics simple methodology to go for multiple choice questions in NEET examination point of view. How are you all, my dear students? Can you please confirm whether I am able to hear? Can you see me? Can you hear me? Right? Very good to see. So what Infinity Learn is doing for the students who are preparing for NEET examination, just is an illustration for you, and you can see 4 students that on board here, Hemadyuti, Ashrita and Akhil Verma and Satyanarayan, they got very less marks in 2023 examination NEET, and after taking certain courses from the Infinity Learn, they got 661 mark. You can see Ashrita 310 to 661 marks, watch an improvement. She got 351 marks. And also Akhil Verma, who got just only 313 marks and 658 marks in 2024. There is a huge improvement of 345 score. Hemadyuti, she got 310 marks and she got secured 652 marks, 342 marks increment you can see. And also you can see Satyanarayan, he got just 330 in NEET 2023 and 2024 650 and 320 marks inka bad gaya. So these are the sample candidatures that I want to show you. More than 100 students got like this, and you just believe in us and study with us, and you will be the next for NEET 2025 examination. Let's go ahead with what we are doing. Crack NEET 2025. For that you all need to attend the classes regularly with various topics that we give you. Hena? Very good to see. My dear students, say hi in the chat box, in the fiery emoji, so that you please confirm, am I audible? My voice is audible and you can see me. Hello? Right. Also you can see, is your test preparation with Infinity Learn. We have live classes on Infinity Learn app, and we have mock test and create your own test 24/7 doubt removal sessions. And also we'll be having all social media. We are connected here with YouTube, Instagram, Facebook, and you have the Telegram also. Telegram channel is given in this डिस्क्रिप्शन बॉक्स. यू कैन क्लिक ऑन टेलीग्राम चैनल सो दैट हमारा क्लासेस का सारा के सारा स्केड्यूल्स आपको बना देंगे, और हर क्लास का जो नोट्स पीडीएफ फॉर्म में भी आपको मिलेंगे, एंड यू विल बी हैविंग डेली क्विजेस एंड डेली क्लास का शेड्यूल भी है, एंड सेशन नोट्स भी है, एंड असाइनमेंट्स एंड मेनी मोर थिंग्स दैट आर एबल टू सी. एंड you can see in the link in the description box. And also you are going to see India's first artificial intelligence based learning experience is from Infinity Learn. From there you can see doubt resolution 24/7, and also you can see it is for every question it is hint, and every time it will be given self study, learn, practice and revise. And also टेस्ट प्रेप का एनालिसिस है, हमारा लाइव क्लासेस का रिकॉर्डिंग्स भी है आपके पास. वॉट एवर यू थिंक योर परफॉर्मेंस इज ट्रैक्ड बाय आर्टिफिशियल इंटेलिजेंस. ओके, सो लास्ट विल बी हैविंग ए स्कोर एग्जामिनेशन, that is India's largest scholarship test, and it is from grade 3 to grade 12. And it is, of course it is online, and it is possible for you guys. Let's make the success possible. How it is? Simply you need not have to connect with Sri Chaitanya or Infinity Learn. You may be from any school or any college, and still you can attend the score examination simply sitting at home, and you can give the examination, and you will be having scholarship worth of 1 crore. Can you believe it? And it is the biggest in India ever. And also study setup and also laptop also be given as a gift, you guys, education allowances BA and up to 100% scholarship and what lot depending upon your performance. Meanwhile, anything you can get it. Can you just digest this one and score? Registration is now open. Attend exam from 9th October 2024. Description box में आपका मिलेगा ये score examination का link है ना, right? So what let we'll start with effect of temperature in chemical kinetics and the collision theory. So far in the chemical kinetics we discussed about the order, molecularity and pseudo first order reactions, and from there in continuing in moving forward we start with Arrhenius equation and get ready what let, and based on this what you are going to learn in today's class: temperature dependence on Arrhenius equation and its graphs and how to calculate various numericals, and previous class का numericals की भी हमारा आज का क्लास में है, and chemical kinetics definitely on an average you will be getting one question from the NEET examination. 4 marks is yours in a short video. You are staying here and I can assure you that after completion of this class you will be doing good in chemical kinetics. Are you ready with that? Are you ready? Okay, now let's talk about effect of temperature. A mixture of magnesium and oxygen does not react at room temperature, है ना, लेकिन आप इग्नाइट करेंगे तो टेम्परेचर बढ़ जाएगा, टेम्परेचर बढ़ जाएगा तो रिएक्शन शुरू होगा, and you are going to, what if burning splinter is introduced into the mixture, अभी जल जाएगा, and it burns vigorously with a dazzling flame, है ना, and you can see similarly a mixture of methane and oxygen does not react at room temperature, but you need to ignite it. As temperature increases, the reaction stick it put in the mixture that burns rapidly. So temperature plays a crucial role. What is that? Why happen like this? Some external agent has to be introduced in order to initiate the reaction. Kapilendra Pangi, good afternoon. Happy to see that you are in the class. Good afternoon. आज क्लास में आप क्वेश्चंस करने का तैयार है मेरा साथ केमिकल कैनेटिक्स का टॉपिक से. सो पहले शुरुआत से हम कोलिजन थ्योरी करना है. ओके, क्वेश्चंस करने का पहले थोड़ा कॉन्सेप्ट भी डिस्कस करना जरूरी है. ठीक है बेटा कपिलेंद्र पंगी, राइट? सो नाउ लेट्स talk about according to the theory, this collision theory, for a chemical reaction to take place, the reactant molecule should come close together and make a collision. And my question is, does every collision gives the reaction? Yes, may or may not. Now in actual, only a little amount of the reactant molecules which are participating in collision can give you the product. Then what is the criteria that makes the collision to be effective? So not all collisions are effective. To give the products, then what is the criteria? So the collisions among the reactant molecules are divided into 2 categories. One is effective collisions, another one is ineffective collisions. Effective collisions are the collisions which actually gives the product, and the colliding molecule should have the minimum amount of energy to give rise the product, and also the collision molecule should have the appropriate orientation to make a collision. So these are the 2 parameters. So let's talk about the energy. The colliding molecule should have minimum certain amount of energy in order to give the product, and that minimum amount of energy, you can say it is a threshold energy. That is called threshold energy or barrier energy. And also, so the effective collisions which bring about the occurrence of a chemical reaction, and ineffective collisions do not have that minimum energy or minimum orientation as well. So orientation and energy should be in appropriate way and should be in the same simultaneously. If orientation is proper but energy is improper, the reaction do not happen. If the energy is sufficient and the orientation is not improper, the reaction do not take place. Like that you can see various. Now the most of the times the molecules of the reactant do not possess the threshold energy. And so in order to make the effective collision, to bring about the chemical reaction, effective collision, सिर्फ effective collisions a reaction product दे सकते हैं, and additional energy is needed to absorbed by the reactant molecule. So कम से कम energy होगा reactant के लिए. ये threshold energy पहुंचने के लिए अब बाहर से कुछ energy देना पड़ता है. That is what you call it as activation energy, and that is what in addition additional energy which is absorbed by the molecule, so they achieve the minimum threshold energy is called as activation energy. This activation energy is indicated as EA. Activation energy is indicated as EA, and in the present it is represented by EA, and you can see the progress of the reaction can be studied in a graph with energy of the reacting system, and you can find delta H EA from the graph. I just want to give that. Look at this graph, and you can see the graph here, all the colliding molecules. You can say this is a graph, energy and a reaction, and it is going to be the like this. This is the reacting species, this is the reacting species, and these are the product, and this is the excess energy that you need to supply to reach the threshold energy is called as activation energy, and this is the energy that makes the difference between the reactant and the product is called as a delta H. That I just want to mention here. Yes, the reactant and it is the product. Let us say A plus B gives rise C plus D, whatever the reaction may be, and energy of the reactants and energy of the products. This is the energy of the reaction delta H. Delta H is nothing but sum of the energies of the products, enthalpy of the products minus some of the energies of the reactant, right beta? And the energy that is excess needed to the reactant in order to reach the threshold minimum energy, that is called activation energy, and this is a very important, and you will be having an endothermic process और एक्सोथर्मिक प्रोसेस भी हो सकते हैं. अगर एंडोथर्मिक प्रोसेस मान लो, यू कैन से दिस इज द रिएक्शन, रिएक्टेंट का एनर्जी है, प्रोडक्ट का एनर्जी है. सो प्रोडक्ट का एनर्जी ज़्यादा है रिएक्टेंट का एनर्जी से, सो दैट you can say this is an endothermic process. Delta H is going to be greater than 0, it is a positive value. Okay, dear children, you can see Kapilendra Pangi, hope you are following the class. Kapilendra Pangi, okay. So the reactant energy ज़्यादा है and इसका product का energy है, so energy is lost. So this is an exothermic process. This is endothermic process, and this is exothermic process. Kapilendra Pangi, and how these activation energy are related we are going to see from the Arrhenius equation. I will show you that. Now in this exothermic process and endothermic process, you can see, in this we can see Arrhenius equation. Arrhenius proposed the equation, the determination of activation energy at a given temperature, that is given as K rate constant is directly proportional to exponent minus EA by RT. EA is activation energy, R is gas constant, and T is your temperature. In this, K is equal to A exponent minus EA by RT. A is called frequency constant or frequency factor or Arrhenius constant. K is reaction rate constant. So this is what you call it as Arrhenius equation. He mathematically derived that. And if you simplifying the equation, take logarithm. So log to the base 10 K is equal to minus A by RT plus log to the base 10 of A. So this appears like equation of a straight line. From this equation of a straight line, you can draw a graph and you can get a slope with a negative slope. From this negative slope, you can calculate the activation energy like this, you can see. So K A EA by RT, and from there you are going to get from the plot when the log K or ln K versus 1 by T is going to be a equation of a straight line. If that is the case, ln A and ln K versus 1 by T, you are going to get a straight line with a negative slope. Slope is going to be minus EA by R. So if slope is given, you can calculate activation energy. This is clearly explained and given a couple of questions from the NCERT in this YouTube channel from Infinity Line. We are going to discuss line by line parameters from this NCERT textbook. You are ready with that? Because we are writing NEET examination. From the NEET examination, we have to stick to the NCERT. Just mind it, no deviation at all, and mind it, from the slope you can calculate activation energy. So it's very important. And also log K is equal to minus A by 2.303 RT plus log A, and if you draw a graph between logarithm to the base 10 K upon 1 by T, you are going to get a straight line. So the slope is going to be a negative slope. From this negative slope, minus EA by R 2.303 R. So you can directly calculate equation activation energy from this, because the log 10 values, log to the base 10 values are given here. And also if K1 is the value of the rate constant at T1, K2 is the rate constant at T2 temperature, and the relation between K1 and K2 and T1 and T2 and activation energy is given on the basis of K1 A EA by RT1, K2 A EA upon RT2. From these two, you can say log K2 by K1 is equal to EA by 2.303 RT T2 minus T1 upon T1 T2. So this is a super formula where you can get a direct numerical from the NCERT textbook, and even in the NEET examination a couple of questions are being given in the NCERT textbook based on this particular formula. You can simply apply it and you can get the appropriate answer, so that there is a huge chance of getting a question from this particular topic, my dear children. And also this equation is called integrated Arrhenius equation. This equation is very useful in determination of activation energy by knowing the value of K1 and K2 at temperature T1 and T2. Right, Kapilendra Pangi? Annamani is there in the class today. How are you? Right. So hope you are understanding. Just give a fire emoji in the class and thumbs up. So let's participate in everybody's discussion. Everybody's discussion in this class in the chemical kinetics Arrhenius equation. Okay. Now let us do question, the decomposition of N2O into N2 and oxygen in the presence of gaseous argon follows the second order kinetics. So the K value is given as exponent 2 minus 2,900 Kelvin upon temperature, and you are asked to calculate this. Okay, what is the energy of activation for this reaction? That is the question. Let us solve this energy of activation. So K is equal to A EA by RT, and given this K is equal to 5 into 10 power 11 liter per moles exponent to 29000 K by T. So this particular parameter is there for this. By comparing the coefficients, minus 29000 upon T, from there EA by RT, you have to equate it, negative negative you are going to cancel it, and you are going to get cancel the temperature. EA is equal to 29000 into R. R value 8.314, you are going to get 241.1 kilojoules. That is the simplest way of solving this type of questions. Mind it, it is correlating the given equation based on this Arrhenius equation, that is K exponent A by RT. Kapilendra, fine beta, right. Now let us talk about one more question here. There is a question, and in a gaseous reaction important for understanding the upper atmosphere. So upper atmosphere में कुछ चल रहा है, and H2O and O bimolecularly combine to form OH radicals. Delta H for this reaction is 72 kilojoules at 500 Kelvin, and activation energy is 77 kilojoules and kilojoules per mole. Estimate the activation energy for the bimolecular reaction of two OH radicals to form H2O and oxygen, the atomic oxygen. For that it is simple, H2O plus O gives rise to 2H2O, and it is given from here to here 77 kilojoules, from here to here 72 kilojoules, and इतना अंतर मिलेगा 77 and 72 से, इतना अंतर है 5 kilojoule per mole. The graph, it can tell everything, okay. And you can say in the previous explanation also it is given like this. So if it is exothermic process, if it is an exothermic process, so this is what you call it as a delta H, okay. You see the color code, okay. This is the reactant and this is your product, and this is the activation energy for the reverse reaction, and this is the activation energy for the forward reaction, like that. So directly from the product to the peak of the curve is the activation energy for the reverse process, and it is an exothermic process. If it is an endothermic process, you can see the reverse. So it is an endothermic process. In this endothermic process, and this is what you call it as endothermic reaction, and activation energy for the forward reaction, and this is what you call enthalpy of reaction. This is what you call it as enthalpy of reaction, and this is what you call it as activation energy for the backward reaction. You can see the color code, you will understand everything. Got it, my dear children? Every point we are discussing here, you all just focus on what exactly you are going to expect it. Fine. And also catalyst. Catalyst, what is the meaning of catalyst? Catalyst is a substance which actually do not participate in the reaction, but it takes an alternative pathway and it impacts the activation energy, it impacts the speed of a reaction. The catalyst may be a positive catalyst or may be a negative catalyst. A catalyst which actually speed up the reaction is called as a positive catalyst. The catalyst which retard the speed of reaction is called negative catalyst. So a catalyst can catalyze those reactions where delta G is negative. ये स्पॉन्टेनियस, सिर्फ स्पॉन्टेनियस रिएक्शंस के लिए ये कैटलिस्ट का काम चलेगा. जिस रिएक्शंस का नॉन स्पॉन्टेनियस है, डेल्टा जी इज पॉजिटिव, ये रिएक्शन नहीं होगा एंड कैटलिस्ट का काम नहीं चलेगा, है ना. कैटलिस्ट कैन कैटलाइज इक्वली फॉर द फॉरवर्ड रिएक्शन एज वेल एज द बैकवर्ड रिएक्शन. देयर इज नो केमिकल चेंज इन द कैटलिस्ट. okay, and the catalyst may have the physical change due to just weathering or wear and tear, right? So kind of knowledge you need to have. So what exactly a catalyst? If a catalyst is said to be a catalyst, if nothing is mentioned, it is said to be a positive catalyst. Kaplendra? And let us say, so what actually a catalyst do? Catalyst takes an alternative pathway which has less activation energy, so that reaction is going to be proceeded with the speed. So for this, reactant is converting into product, and this is the graph path without a catalyst, and this is the path with the catalyst. So catalyst is going to choose alternative pathway where less activation energy is seen. So जल्दी से reaction होने का तैयार करते हैं. And also see characteristics of the catalyst. We discussed every point of the characteristics of a catalyst. A catalyst never and ever initiate the reaction, rather it enhance that reaction speed by changing the reaction pathway in a different way. Okay, since the catalyst, just a minute. So, certain chemical reactions, consider the reactions. 2N2O5 gives us 4NO2 plus O2. In this reaction, NO2 being formed as the rate of 0.0125 mole liter inverse second inverse. What is the rate of the reaction? Various formats are given. Who is going to give the answer? Kapilendra and other students. And we are going to discuss now in various parts of the chemical kinetics multiple choice questions based on NCERT. Okay, we selected certain questions. You get ready with that. Who is going to give the answer? I want you to give the answer in the chat box. Fatafat, students who are active, please give the answer, so that, arey beta, this is an interactive session. So the interaction between you and me. Come on, make it faster. Who is going to give that answer? Right. So let's see how to solve this question. So rate of a reaction is mentioned. So N2O5 gives us NO2 plus O2, and rate of formation of NO2 is given as 0.0125, 0.0125, and rate of a reaction is equal to 1 by 4 into rate of formation of NO2 into 1 by 4 of 0.0125. How do you write this as 1 by 4? So this is 1 by 2 dN2O5 and dt is equal to 1 by 4 dNO2 upon dt is equal to dO2 by dt. I just want to say dNO2 upon dt. So this value is 1 by 4 into this is nothing but your answer, 0.0031 mole liter inverse second inverse is the answer for this question. So like that, every line present in the NCERT we are going to discuss, and based on that we are going to discuss a question and simplified methodology to solve a question in the numerical part, and it is a physical chemistry. You all with that can do the best. And one more, in a reaction to HI plus gives rise H2 plus I2. The concentration of HI decreases from 0.5 to 0.4 mole per liters in 10 minutes. What is the overall rate of a reaction in this given interval of time? Who is going to give this answer? Make it fast. Make it fast. ठीक है? Well, it can be average rate of the reaction is given as minus Hi upon T, that is 2Hi, so 1 by 2 is equal to d H2 upon T d I2 upon T. So rate of a reaction is equal to 1 by 2 into change in the concentration difference between these two upon 10 minutes. So you are going to get 5 into 10 power minus 3 minute inverse. So 5 into 10 power minus 3 minute inverse, that is going to molar minute inverse. Mole per liter minute inverse. Molar means mole per liter minute inverse. So that you are going to get the option A as the correct answer. So unit conversions is also very important. My dear children, you please be active in the chat box so that we can do the best for this session. And one more question. For a reaction R gives rise to product, in this the concentration of reactant changes from 0.05 to 0.04 in 30 minutes. Simply just like a previous question, you can get it. If you analyze the last 10 years medical entrance examination questions, the question looks like same only, but you will be having a different version of the conversions, a different version of the solutions. So what will be the average rate of reaction in the minutes? So simple, you can say rate is going to be change in the concentration upon this time interval 30 minutes. It is given 0.05 से 0.04 तक जा रहे हैं. So R2 minus R1, and it is going to be 3.3 into 10 power minus 4 mole liter inverse and minute inverse. I said I can guarantee you that at the end of the session you can pick a very good question numbers from various parts of the NCERT related questions. So stay with us, we are going to discuss some more questions with us so that your answer is going to be C for the same. Got it, children? Nice. If you have any doubts, you put your doubts in the comment box and chat box so that we can have a discussion. You can have a discussion, right? Now let's talk about units of the rate of a reaction R. Units of a rate of a reaction are nothing but concentration and time inverse. That is the key point. Whenever it is given that is the concentration, it is nothing but mole liter inverse second inverse. So I just want to say concentration and time inverse. So it could be concentration means a mole liter inverse second inverse, or mole liter inverse minute inverse. It could be anything, or atmosphere minute inverse, or atmosphere second inverse. Like that, various levels of conversions are there, and choose the correct value of D NH3 by dt for the reaction. Make it. So Haber's process synthesis of ammonia. In the Haber's process synthesis of ammonia, it is going to be dN2 upon dt, okay, 1 by 3 dH2 upon dt. I just want to make a minus and minus. Here it is going to be a plus. Why? Because minus sign indicates the decrease in concentration, plus sign indicates the increase in concentration. It is going to be dNH3 upon dt. It is like that. From based on that, you can take this fraction in that side, and it is choose the correct answer. It is going to be 2 by 3 dH2. So why? Because 2 by 3 d, so this one comes here, 2 number comes here. Then you will understand rate of formation of ammonia. Now let us talk about the rate of a reaction expressed in different ways as follows. Something is given like that. Based on that, जो भी fraction है ये यहाँ लिख सकते 2c, ये fraction है 3d, and it is going to be 4a plus b. So that is your answer. Simple in the reverse way. Reverse way you can give the equation for that is said to be option B. Okay. So that 2, 3 you have to get 2, 3. Oh, okay. It is C now, right? It is C now. It is supposed to be plus. Okay, in the other side. okay, right, it is going to be C that side and A that side, and it is going to be B plus 3D, and you are going to see for the reaction 4NH3 plus 5O2 gives rise 4NO plus 6H2O. If the rate of disappearance of NH3 is 3.6 into 10 power minus 3 mole liter inverse second inverse, and what is the formation of H2O? For this equation 1 by 4 NH3 dNH3 by dt, 1 by 5 dO2 by dt, and 1 by 4 dNO by dt, and 6H2O and 1 by 6 H2O by dt. And from there you can see, so the rate of, given that NH3 by dt, rate of decomposition of ammonia is given as 3.6 into 10 power minus 3. So you can just check it here, rate of disappearance. So relation between NH3 consumption and formation of H2O is the relation 1 by 4 NH3 by dt is equal to 1 by 6 H2O by dt. Based on that, this value, if you keep it, it is going to be 5.6 into 10 power minus 3. That is the simplest way of doing rate of the reaction kind of calculations over here. And also it gives the answer is going to be 5.4 into 10 power minus 3, my dear children. And one more question, in a reaction आप करना है ये सेशन में आप आंसर देना अच्छा होगा. And 2A gives rise to product, the concentration of A decreases from 1.0 mole per liter to 0.8 mole per liter in just 20 minutes. Calculate the rate during this interval. So you have to take the difference between these two, and in the minute inverse only the values are given, and in 20 minutes you just check the values. You can say minus 1 by 2 A upon T is equal to minus 1 by 2, and change in the concentration A 1.0 1.8 का अंतर 0.2 होगा upon 20 minutes. It is going to be उसमें आधा 0.005 mole liter inverse and minute inverse. That is going to be the answer for this question. Answer B is the correct answer for this question, right? Children, any doubt you may please ask in the chat box. So today we are discussing about NCERT based हर लाइन का टॉपिक डिस्कस किया गया, एंड हर लाइन का टॉपिक का हिसाब से हम क्वेश्चंस भी कर रहा हूँ. So if you check this last a few years previous year questions from the NEET examination, आपका आंसर इतना के अंतर है. And here a question can be given based on the orders and the other criterias. For a reaction for P plus Q gives rise to R plus 2S. Which of the following statements are true? So for that I can write, so that is 1 by 4 dP upon dt is equal to dq upon dt is going to be 1 by 2 dr upon dt is equal to 1 by 2 ds upon dt. So based on that you can directly write it. And I just want to say option D, the catalyst catalyzes the backward reaction. The catalyst influences the forward and backward reaction the same extent, and the catalyst increases the rate of forward reaction and decreases the rate of backward reaction. So I just want to say catalyst catalyzes both forward and backward reactions in the same phase. So my answer is going to be here C is the correct answer. It's a theory oriented question. It's a theory oriented question. Getting or not? Getting or not? Very nice. Let's take about for a reaction 2A plus B produces the order with respect to A is found to be 1 and with respect to B is found to be 2. So rate is equal to K with respect to A is going to be 2, with respect to B is going to be 1. It's a trimolecular reaction, but concentration of A is doubled and the concentration of B is halved, the rate of the reaction. So A is doubled means it is reaction with respect to A is quadruples, 4 times, and B is halved means with respect to B it is going to be half. So based on that you are going to get the new rate is going to be half the rate of the initial. So that I just want to say it is halved. Understand? Clear? Okay. And also you can see for a reaction same way A plus B gives rise to C plus D, my dear children. Here the concentration of both reactants increases the rate reaction by 8 times and double the initial concentration. Sirf B, the reaction rate is double, the rate law is going to be. So we have to use the conditional rate equations. Okay, so for as per the first condition, it is based on the NCERT textbook, rate 18R if the condition A is doubled as well as B is doubled. So let us मान लो X is the rate with respect to A and Y is the rate with respect to B, and rate 2 is just 2R K A to the power X and 2B to the power Y. You take this equation 1 and equation 2, just equation 1 by equation 2 comes to be on solving X is equal to 2. X is equal to 2. Similarly, also you are going to solve for this Y is equal to 1 and it is said to be rate law K A square and B to the power 1. So that A square B to the power 1 option is going to be D. This kind of logical approach questions are very important for NEET examination. Hope you are doing good. Any doubt, children? So we'll do one more question. The conversion of molecules Y in X to Y follows the second order kinetics if the concentration of X is increased 3 times, and how will that affect the rate of formation of Y? It is a second order reaction. So if you just check it, the reaction X to Y rate is equal to K X square, it is said that second order का हिसाब से, so that if the concentration of X is increased 3 times, so you can say rate dash or rate 2 is going to be 3 times is increased X square, so K 9X square. So on dividing this equation 1 and this is equation 2, and you are going to get new rate upon the initial rate is equal to K 9X square upon K X square. I just want to strike K, I just want to strike X, so that you are going to get 9. So the reaction of the formation of Y is going to be 9 times. Got it? So you can see kind of logic oriented questions in this NEET examination point of view, dear children. These are the methods we need to do in a simplest way. And also before we end the class, so it is 9 times, it is A, it is given as 9 times. Got it? Let's talk about unit of the rate constant for a 0 order reaction. Who is going to give the answer for this? Make it fast, fatafat, clear. Yes, it is for 0 order reaction, for 0 order reaction, rate dimension is equal to rate constant. How it is? Rate is equal to K A to the power 0. Anything power 0 is equal to 1. So rate is equal to K. So whose value is going to be mole liter inverse second inverse is the correct answer for that. Mole liter inverse and second inverse. So my answer is going to be game of our child. So where did you go so far? We are all expecting your presence. Okay, so it is given as this one. And also equilibrium constant reaction is 20.0 at equilibrium. The rate constant of forward reaction is 10 and the rate constant of backward reaction is. I just want to simply say, according to law of equilibrium, Kc is equal to rate constant of forward reaction upon rate constant of backward reaction. Okay, so that forward reaction and backward reaction is given, so rate constant has to be calculated based on that. I have a, yes, okay. Now you can see equilibrium constant is equal to rate constant of backward reaction upon rate constant of backward reaction, forward reaction. Equilibrium constant is given as 20, forward reaction is given 10, backward reaction is 10 upon 20 is equal to 0.5. It is the law of chemical equilibrium. Hey Kina, understand my dear students? Clear? Clear? Very good. Now we'll do one more. Here for the reaction 2A plus B gives rise to D plus E. The following reaction has been proposed. A plus B gives rise to C plus D is slow and A plus C gives rise to E is a fast. The overall reaction is going to be, so 2A plus B gives rise to D plus E, है ना? And the reaction can be expressed for the reaction. So which reaction? So always slow reaction is the rate determining step, or DS, it is a rate determining step. If we follow this rate determining step, it is going to be iska A and B has to be written. So I just want to say rate is equal to K A B. Clear beta? Any doubt? Graham of our child, Kapilendra Pangi, Anna Mani, many students are seen in the visual board, and today we had a great discussion with Arrhenius equation, temperature dependence, activation energy for endothermic process, exothermic process, threshold energy and frequency factor, and various graphs and simple NCERT based numericals from the chemical kinetics we discussed. And I request you guys, you please follow these same methodologies to crack your NEET examination. Please like the session and share with your friends and subscribe to Infinity Line NEET channel, and also you can just check the Telegram channel in the description box so that we can join there and you can get all session updates and session notes as well. Okay, so we had a great swell of session. Signing off, Suresh, Faculty of Chemistry from Infinity Line. Thank you very much. See you.